Guys, in this video we are going to see an example on application of first order differential equations in mixing concentrations. Let's look at this problem right here. This question is asking a large tank holds 300 gallons of brine solutions with 40 pounds of salt. A concentration of 2 pounds per gallon is pumped in at rate of 4 gallons per minute. The concentration leaving the tank is pumped out at a rate of 3 gallons per minute. How much salt is in the tank after 12 minutes? Now, in order to solve this problem, first of all, we have to find the particular solution of this differential equation. Now, let's find the general solution. So, in order to do this one, we have to find these values. Here, the dA by dt represents the change in amount of salt, right? Salt per minute. So change in amount of salt per minute, and R1 represents the rate of salt pumped in per minute, and also R2 represents the rate of salt pumped out per minute, right? Now let's go ahead and write the differential equation, that is dA by dt is equal to R1 minus R2. R1 can be calculated by multiplying these two together. Here we have the concentration of the salt, that's 2 pounds per gallons, and we have the rate that pumped in is 4 gallons per minute. Now to find the pounds per minute, we have to multiply these two, right? We can see the units going to cancel each other, the gallons going to cancel each other, and we will get the unit in pounds per minute. That's what we want. And here we have the concentration, that is 2 pounds per gallons, and that's multiplied by 4 gallons per minute, and if you multiply these two together, that's going to give you 8 pounds per minute. So this is going to be the R1. Now to find R2, since R2 is changing, we cannot use this 40 pounds, so we have to use a general number, let's say A. So this is an unknown value. And also we cannot take 300 gallons, because if you look at this one, this is the pumped in rate is 4 gallons per minute, but the pumped out rate is 3 gallons per minute. So each time 1 gallon is increasing, right? So what we have to do is we have to put 300, and in each minute 1 is increasing, so we can put T right here. So T mean as the minute increase, this is going to increase. That's what this is going to represent, and this is our concentration. And we have to multiply this one by pumped out rate, that is 3 gallons per minute. 3 gallons per minute, and if you multiply these two together, that's going to give you 3A over 300 plus T. So this is 3A over 300 plus T, and this is pounds per minute. Now we can write this one in the differential equation pattern. dA by dt is equal to R1. We found out that is 8 pounds per minute, so we can just put 8 right here, and R1 is, this is R2, right? R2 is 3A over 300 plus T, so this is going to be 3A over 300 plus T. And if you look at this one, this is the first order linear differential equation, and the standard form should look like this. We have to rearrange this one to bring the standard form. That's going to look like this: dA by dt plus 3 over 300 plus T times A is equal to 8. Now you can recognize this is our first order linear differential equation, and to solve first order linear differential equation, what we do is we pick up the P of t value. This is our P of t value, whatever the value that's multiplying this A, that's P of t value. So here our P of t value is this one. P of t value is going to be 3 over 300 plus T. Now P of t value is useful to find out the integrating factor. So integrating factor equation is mu of t is equal to e power integration of P of t dt, right? Now we can plug the P of t in this equation to find out the integrating factor. So this is going to be e power integration of 3 over 300 t, actually 300 plus t, I forgot the plus right here. Okay, so this should be 300 plus t, and this is going to be 300 plus t dt, and 3 is a constant, we can move that one to the front. 3 is a constant, and also 1 over 300 plus t, if you integrate that one, that's going to give us ln 300 plus t. So this is going to be e power 3 ln of 300 plus t, right? Also we have constant, but we don't have to worry about when we find the integrating factor, because at the end, after we plug this in value, we are going to create a general constant, so we don't have to worry about constant for now. And here this 3, we can move this one as a power, so this is going to be e power ln 300 plus t power 3, and since we have e and ln together, we can cancel these two, and that's going to give us 300 plus t cube, and this is going to be our integrating factor. Now after we find out the integrating factor, what we have to do is we have to multiply both sides of this differential equation with the integrating factor. So we are going to multiply this side and the other side by this integrating factor. That's going to be 300 plus t cube, and also I have to do the same thing in this side. So this is going to be 300 plus t cube, and after we multiply with the integrating factor, we have to integrate both sides. So this is going to be integrate respect to t, so this is going to be integration of dt, and also this side I had to do the same thing, integration respect to dt. And here the interesting thing about first order linear differential equation is when you multiply, this one by integrating factor, and you get this one, right? Integration d, I separate this d by dt alone, d by dt, and you can write a and 300 plus t cube, right? And if you find the derivative of this part alone, d by dt, this a 300 plus t cube, if you find the derivative, you will get the whole thing back. That's the reason to find out this integrating factor that make this one possible to keep this one alone, right? So this is equal to this one, this whole thing. Therefore this must be equal to this other side. In the other side, if you integrate this one, for example, if you find this one hard to integrate, you can think it like u is equal to 300 plus t, and therefore dg is going to be equal to dt, right? So if u is equal to 300 plus t, we have u cube right here, and 8 is a constant, so we don't have to worry about 8. We can keep it 8 as it is. And if you integrate u cube, that's going to be u power 4 divided by 4, and we know the u value we picked up 300 plus t, so we can plug that one back, and that's going to give us 300 plus t power 4 divided by 4, and also we have a constant, right? Now we can cancel these two. This is going to be just 2, and in the other side, this one, if you integrate, here we have derivative and integration together, so these both will cancel each other, so we will only get this part. This is going to be a times 300 plus t cube is equal to 2 times, I'm going to multiply. Okay, I cannot multiply. I keep this one as 2 times 300 plus t power 4 plus constant. Now if we multiply, we can simplify this one furthermore. I have to get rid of this part because we need some space. Okay. Now we have got this one. Now let's copy this one down right here. Okay, I'm going to copy this whole thing down. A times 300 plus t cube is equal to 2 times 300 plus t power 4 plus constant. Now okay, this is power whole power 4 t power 4, and if you look at this one, we can divide everything by 300 plus t cube. In that way this will cancel each other. Like to show this one, I saw with a different color. 300 plus t cube, we are dividing everything by 300 plus t cube, and also this one by 300 plus t cube, and if we divide, this is going to cancel each other, so we are going to get just a, and in this side we are going to have 2 times 3 cancels, 1 left, so this is going to be 300 plus t, and after the c we are going to have 300 plus t power minus 3, and this is going to be the general solution for this differential equation. We can also simplify this one furthermore, like 600 plus 2t plus c times 300 t minus 3, c times 300 plus t power minus 3. So this is going to be the general solution for the differential equation. Now to find the particular solution, what we can do is, since we have the initial condition, we know that this is a of t, right? And we have the initial condition provided, that is a of 0 is equal to 40. So if we plug this one in this equation, we can find the value for t. Let's go ahead and do that. So here we are going to have a of 0, that is 40. 40 is going to be equal to 600 and t is 0. So 2t, this is going to become 0. We are going to have 600, 2t is going to be 0. C times this whole thing is going to be 300 power minus 3. So this is going to be plus 300 power minus 3. Yeah, 300 power minus 3. And also we have c in front, right? C is what we are trying to find. C times, okay, let's write this one in a better way. C is 300 power minus 3. Now we can move this one in the other side, so this is going to be c times 300 power minus 3 is going to be equal to negative 560. Therefore c is going to be equal to negative 560 times 300 power 3. Because here we have 300 power minus 3, it means 1 over 300 cube. And if we move to the other side, that's going to become 300 cube. Multiply this one. And if you multiply these two together, that's going to give you negative 1.512 times 10 to the power of 10. And if you want to write this one in a whole value, this is going to be equivalent to, okay, let's write this one like this. Okay, this whole thing is equal to negative 1512, and we have moved 3 units already, so we have 7 units left. All of them are going to be 0, so this is going to be 0, 0, 0. We are going to have 7 zeros right here. Okay, so this one should be, let's get rid of this comma. Okay, the whole value is going to be like this. Now if I plug this one in this equation, that's going to be the particular solution for this differential equation, right? So let's get rid of some of these parts. We need some space to solve the main problem. Okay, so now we have particular solution. Let's write down our particular solution. Our particular solution for this differential equation is going to be a of t is equal to 600 plus 2t, and instead of c we can plug this value, that is 15 billion. Okay, this is negative, so I had to put the negative in front. So this is going to be negative 15 billion 12 million to 15 billion 120 million. Okay, 120 million, and that's it. So this is how, also we had to multiply this one by 300 plus t power minus 3, 300 plus t power minus 3, and this is going to be particular solution for this differential equation. Now the question here is asking how much salt is in the tank after 12 minutes. Now all we have to do is plug the 12 for this t. So we are going to find a of 12. A of 12 is going to be 600, and 2 times 12, that's going to be 24. So this is going to be 24 right here, and 15 billion 120 million times 300 plus 12. So that's going to be 312. 312 power minus 3, and if you find this value using calculator, you should get 126.12 pounds of salt. And that's going to be the final answer for this question. I hope this helps. Thanks for watching.